Hello everybody, we are Maria Yingfon Nuribe de Godoy, and today we're going to explain the qualitative analysis. The qualitative analysis is the determination of non-numerical information about chemical species, a reaction etc. The definition is a qualitative analysis is a branch of the chemistry that deals with the identification of elements or grouping of elements present in a sample. This analysis can tell you whether an atom, an ion, a functional group, or a compound is present or absent in a sample, but it doesn't provide information about its quantity. That's a quantitative analysis, that it's more reliable. Whether the qualitative analysis is cheaper, faster, and easier. The characteristics in the sample that are frequently thought to be in investigation are the color, smell, melting point, reactivity, and the precipitation, and so forth. We can classify the qualitative analysis in the organic one that determines the chemical bonds, type of molecule, and functional groups, and we normally use the Yodon test. And then we can find the organic one that normally looks at the elemental and ionic composition, usually by examination of ions in aqueous solution. Normally we use the flame test that we're going to explain later.
In qualitative analysis, we have several methods to identify the compounds of the experimental sample. Some of them are in this slide. So, firstly, we are going to focus on explaining an example of organic analysis and another one for inorganic analysis. For the first one, we can use a changing color test to determine the pH of the sample. For example, here, and as we have learned in biology this semester, we use phenol red to assess pH in tissue culture media. So if we have yellow color, it indicates that its pH is lower than 6.5 and there's an increase in CO concentration. And if it's pink, it indicates a basic pH. So our optimum pH for tissue culture media is an orange color because it indicates that we have a physiologic pH 7.4. Now let us consider an example of qualitative inorganic analysis. As we can see here, we have the flame test. This one is an analytical procedure used in chemistry to detect the presence of certain metal ions based on each element's characteristic emission spectrum. This test we have already studied last year in chemical elements, and here we can see some examples of metal ions and their color. It is used because some of them are solid in water, and if we add acid, it doesn't precipitate. So we use this method to determine which metal we have by looking at which color flame is. So now we are going to see some applications of qualitative chemical analysis. Distillation here is a typical qualitative and quantitative method in the petroleum industry. This test is essential for the quality control of this type of product because of the extensive information that can be extracted from the interpretation of its results. An application of the precipitation method in qualitative analysis is the separation of ions. For example, we have here a diagram which means that ions could be eliminated in groups from the underlying aqueous solution after each group has been isolated. At that point, testing is led for the individual ions in each group. And here we have the different groups that we could separate these ions. Chromatography and spectroscopy are used in different areas of the industry and investigation, for example, in medicine to identify different proteins. So, in a nutshell, qualitative analysis uses different techniques like distillation, chromatography, etc. to determine the presence of different chemical components in a sample. In some cases, it is necessary only to verify the presence of certain elements or groups for which a specific test applicable directly to the sample might be available. More often, the sample is a complex mixture and a systematic analysis must be made in order that all the constituents might be identified.